So I have the current version of WWHM 2012. Why do I need WWHM? That's what we're going to break down here in this video. If you missed part one, where we talked about the #1 stormwater problem that we have today, the fact that we can't integrate all of our stormwater modeling into one software is a huge problem for engineers. That's what we covered in part one. You can see that in the description box down below. Now we're going to talk about if I have WWHM, which I know can do continuous simulation hydrology modeling for me inside my facilities, why would I want to move to something like WWHM when I already do that there? Now we kind of covered why in the #1 stormwater problem, but we're going to talk about it more in depth in this video, why it could be really advantageous for you to move from WWHM 2012 to something like WWHM and help improve your workflow and your ability to create great designs. Now we know WWHM 2012 is a great tool for continuous simulation hydrology and modeling. It's great at designing mitigation facilities, ponds, bioretention, on it goes. It does a great job at that. However, it is incredibly limited or has almost none at all in terms of hydraulic modeling capabilities. We sort of tried to tackle that in things like WWHM4, but have really mastered that when we get into WWHM. So what I'm going to do is we're going to think about a sample project in WWHM 2012 that will show you why moving to WWHM could be really advantageous for you when it comes to your future designs. Let's take this sample WWHM 2012 project. We're going to start our project off. We're going to put some land use in our pre-developed basin, select our project location. So now we've put the pre-developed land use in there. We're going to run the scenario to generate that pre-developed runoff. Next, we're going to build out that mitigated scenario. So we're going to put in the land use basin. There's going to be some impervious area in this one, causing us not to meet that flow duration standard. It's going to cause too many erosive flows, obviously. So we need a mitigation facility. We're going to select this trapezoidal pond. We're going to model that next. Now, there's a lot of ways we could do this, but the best way probably in WWHM 2012 is using AutoPond. So that's what we're going to do. Now we've got our facility sized, we would go to the analysis, and we now see that it does meet the flow duration standard. Great, I've modeled this very simple project in WWHM 2012. What's next? Well, we know that there's more to stormwater modeling than just setting up a basic model like this. There's catch basins, there's pipes, there's hydraulic operations involved. So we got to figure out how are we going to take that data that we got from WWHM 2012 and move it to now hydraulic modeling systems. And before WWHM, this is how we would have to do it. We'd have to take the basin hydrograph data, that's right, we'd have to take the data from the basins, we'd have to export it from WWHM 2012, and it follows this very complicated process. You have to export those hydrographs, turn it into spreadsheet form, and now we have to find a way to input it into a software that can do accurate hydraulic calculations. This example, we're going to select EPA-SWM. So now we have to build out our EPA-SWM network, matching our project that we did in WWHM 2012 using junctions, conduit elements, and so on. But there's no data for it. So what we have to do is export that data from WWHM 2012, bring it into EPA-SWM, which is a confusing process on its own. And now that we've done that, we now have that data in EPA-SWM. Oh wait, except something in our project has changed. We got to go back and make some changes to our initial design. Now that means we have to re-export the hydrograph data that we did in WWHM 2012 and bring it back into EPA-SWM and repeat the process all over again. So what is the solution for this? Well, we would suggest using WWHM instead. Here's how we build out that project. Instead of taking the hydrograph data from WWHM, moving it over back and forth, here's how you could do it in WWHM. We'd build out that exact same project, run the pre-developed and mitigated runoff, insert that mitigation facility, except now we can also insert different swim elements in there. Instead of moving the hydrographs back and forth, we now have the integrated swim elements. We can run swim-specific events based on the time series and amount of time in which event we selected. And now we can run it as one integrated project and get one integrated result as opposed to bouncing back and forth. We can now look at one cohesive set of analysis data and report from this entire WWHM project. So you can see just from that example project, WWHM has a huge advantage over WWHM 2012 when it comes to using hydraulic elements and integrating it in your projects. We see we're able to model the entire hydrologic and hydraulic process in that entire project in WMSWM. Instead of having to use two softwares, we've got Excel open to transfer our hydrograph data. It just became an entire mess. We can all do it in one in WMSWM. And this is a very basic example that we used here. As things get more and more complicated, this difference gets exaggerated, and the amount of time that you need to move these things back and forth when using WWHM 2012 just exponentially grows. So you want to stay tuned for part 3 as we show you more features and more uses for WMSWM and how they can be used in your projects for your future designs. If you have any questions, leave a comment down below and we'll see you guys in the next video.